So in this video, we're going to look at multiplying imaginary numbers. And the first thing we want to look at is a core principle in imaginary numbers, which is the negative or the square root of -1 is equal to I. But now let's see if we can figure out what I squared is equal to. So what we can do here is we can say, okay, I can be replaced with the square root of -1. And if I take the square root of -1 squared, it actually just gives me -1. Because anytime you square a square root, they basically cancel each other out, and you just get left with what's on the inside. So what we can essentially say is, moving forward, I squared, if we ever see I squared, we can replace that with -1. So now we're going to use that to try to do a problem like this. I to the 15th. Now, we could go through this and just basically go I to the 3rd, what's that? I to the 4th, what's that? I to the 5th. And we could just do that all day. But there's actually a quicker method, so let me break it down and try to show you what it looks like. Now, the first thing we want to do is we want to try to rewrite 15 as a even number. Okay, you'll see why in a second, but first let's try that. So I to the 15th, we're going to use our exponent rules to break down this I so that we have I to a number times I to another number. Because basically, when we multiply variables and they have exponents, we add the exponent. So let's see if we could take 15 and make it an even number by rewriting it, which we could. If we make this 14, I could say I to the 14th times I to the 1st. That would be the same as I to the 15th, because remember, we just add the exponents when we're multiplying. So that's my first step. Okay, so your first step is rewriting using exponent rules to make this 15 an even number. Okay, now what we're going to do is isolate or focus in on this I to the 14th. Is there a way to rewrite I to the 14th using exponent rules so that this is I squared set to a power to get me back I to the 14th? Well, if you remember, I squared, if I set that, let's say, to the power of 7, I'm actually going to multiply my exponents. So it's a power rule problem where when you raise an exponent to a power or raise an exponent to an exponent, you multiply the exponents. So this I squared to the 7th would actually be how I rewrite I to the 14th. But then I still have this times I here. Now, hopefully you're wondering, why the heck are we doing that? Well, we said at the very beginning, I squared is equal to -1. So now I can replace I squared with -1, and I can do -1 to the 7th power, because if I have -1 to the 7th, essentially any odd number is just going to make this -1 stay negative. So this would give me -1 times I, which would equal -I. All right, let's do another example. Let's say I wanted to do, I don't know, we can do a simpler one, I to the 5th. Okay, let's say I wanted to do I to the 5th and figure out what is that equivalent to, or simplify this. Well, first, I want to rewrite this so that it has, we can make this 5 an even exponent, which we're going to have to go down, so we'll make it I to the 4th. But then in order to get back to I to the 5th, I have to multiply this by I. So now what I can do is try to rewrite I to the 4th as I squared set to a power to give me this 4 back. And it would actually have to be set to the power of 2, because remember, we're multiplying our exponents. So now what that allows me to do is replace this I squared with -1, and -1 squared is just 1, so this would leave me with I. All right, let's try one more, and then we'll move on to the next part of this. So let's say I have, we'll do a big one, I to the 67th, or 62nd. Now, 62 is already an even number. So what we want to do is see if we can rewrite I squared to a power to get back 62. Now, once again, a simple way you can do this is you could literally just divide this number by 2, and that's the number that you're going to raise this I squared to, which that would be 31. All right, because if you think about it, I squared to the 31st, we multiply the 2 and 31, and that would give me back 62. All right, so now I can replace I squared with -1, and -1 to the 31st power, since this is odd, is just going to become -1. So that would be how I do this. Now, the whole reason we're doing this is so that we can do problems like this. Let's say I have 4i times 7i. Well, I'm going to treat I as a variable. So when I multiply this, I'm going to do 4 times 20, or 4 times 7, which is 28. And then I'm going to do I times I, which is I squared. Because remember, when we multiply variables, we add the exponents. So if this is I to the first and I to the first, that gives me I squared. So now, a lot of people would say, okay, I'm finished. But I'm not. Because I squared, remember, is -1. So I could say this is 28 times -1 and replace that I squared with -1. So this would be -28. So that's the whole point of doing this. Like, let's do another example. We could say, let me get rid of all this. All right, we could say, let's do -4i times 2i times -9i. All right, so now, once again, we're just going to multiply this just like we did before. -4 times 2 is -8. -8 times -9 is going to be 72. So we have 72. Then we're going to multiply I times I times I, which is I to the third. And once again, a lot of people think, well, I'm finished here. Basically, unless you have unless you're just left with an I, you're not finished. Anything bigger than I to the first can be reduced. So we could reduce this by saying, okay, this is 72. I can say I to the third is I squared times I, and now I can replace this I squared with -1. So that's going to give me a negative out here in front of 72, and then this I is just going to tack on to the end. All right, let's look at another example. Let's say we have, let's say we have 2i to the third, but it's actually all to the third, the 2 i's to the third, times 5i. Now, when I multiply, or when I set this entire thing to the third power, I actually have to do 2 to the third and then I to the third. So that's going to give me 8i to the third times 5i. Now, 8 times 5 is 40, but then I to the third times I is going to give me I to the fourth. Now, I can take this and I can rewrite it so that I can get rid of this I to the fourth. So once again, 40, I can rewrite I squared, but I can rewrite that to the second power so that I still have I to the fourth if I were to go backwards. And now I can replace this with -1 squared, and now this would just give me +1, so this would equal 40. All right, let's look at another. Let's say I want to do this problem. Let's say I want to do the square root of -18 times the square root of -10. All right, now, this can get a little confusing, but here's what we want to do first. The first thing we want to do is take out these negatives. So hopefully we remember I can replace a negative inside the radical with I on the outside of the radical. All right. So this would give me I radical 18 times I radical 10. And what I can do is I can multiply these coefficients. It would give me I squared. And then I can multiply 18 and 10, but leave it under a radical. So it would be the square root of 180. Now, I already know that I squared is just -1. So this is going to become negative square root 180. I'm just going to keep this negative on the outside of my square root. So now when I break down the square root of 180, let's see, I need the biggest number that's a square root of, or a biggest number that divides 180 that's also a perfect square. And that would be 36 and 5. So I could break this down to negative square root 36 times 5. And the square root of 36 gives me 6. So this would be -6 radical 5. So let's just do one more just for the sake of doing it. let's say I want to do the square root of negative 24 times the square root of negative 3 times the square root of negative 2. So first I'm going to take out all these negatives and make them i's on the outside. All right. Then I'm going to multiply. So first, I times I times I gives me I to the third. 24 times 3 times 2 is going to give me the square root of 144. So now I want to try to rewrite I to the third. And I could rewrite that as I squared times I, which is just going to give me negative 1 times I. So that's going to give me negative I square root 144. And now, what's the square root of 144? Well, it's just 12. So then this negative comes down, I comes down, so the answer is negative 12i. So once again, this is very good information because as you move through imaginary numbers and using imaginary numbers, a lot of these skills will pop up.